Okay, next portion I'd like to take a look at here is something called the conservation of energy. Now, ultimately, I'm sure this comes down to a something you've probably heard before, where energy can never be created nor destroyed, and this is a true statement. So far, this has never been proven to be incorrect. Basically, what happens is energy is transformed or transferred from one type to another. Now, we typically deal with energy transformation. This is specifically if an object is kind of changing how it's moving. This would be what we call transformation. Transfer occurs whenever there is one object hitting another object, and the energy from that first object is transferred to the second object. Think of taking a cup of water and dumping it from one cup into another cup. That first cup represents one object, and then the second cup represents the second object. We've taken the energy, in this case water, dumped it from one cup into another. So transformation, when we deal with this, typically we are going to have the transformation occurring because of some kind of force that's mediating this transformation. In the case of our systems that we deal with when we have the conservation of mechanical energy, we're dealing with something called an isolated or a closed system. So let's take a look at a kind of a specific example of what this might look like. So here we go. We have, and again, this is nowhere near to scale, so just you can ignore that. But basically, we have the Earth here, and then we have some ball that's lifted some height above the Earth. Now, because it's lifted above the Earth, it does have potential energy. So the system that we're dealing with is the ball and the Earth. Notice that the forces we're dealing with here are both within the system. So these are sometimes what I refer to as internal forces because they're not coming from an external source. They're coming from the parts of the system, in this case, the ball and the Earth. Now, as the Earth pulls down on the ball and the ball pulls down or up on the Earth, let's focus mainly on what the ball does. The ball is going to fall towards the Earth, and as it does this, it's going to get faster, and it's going to gain some velocity in this direction. As a consequence of falling closer to the Earth, its potential energy, in fact, let me change this up. I always use purple for energy, so I'm going to change to a purple marker. Its potential energy has decreased because it's now closer. Its height is less. But as a result of falling, the kinetic energy of the ball has actually increased. So there's maybe a 10 joule decrease in potential energy, but there's a 10 joule increase in kinetic energy. The energy is simply moved from one place to another. It is transformed in that object. So again, that ball had potential energy to start, and it is going to transform into kinetic energy. Now, a couple things when you look at these systems and you look at energy, some things I want you to think about. Some questions you're going to ask yourself. As far as kinetic energy goes, you want to ask yourself this: is it moving? If it is moving, then its kinetic energy will be a non-zero. In other words, it will have kinetic energy. If the object is not moving, if the answer is no, then the kinetic energy is zero. All right? Consequentially, with gravitational potential energy, you want to ask yourself, is it above the ground? And if you can answer yes to this, and again, by ground here, I'm referring to the level here that we specifically called our zero level. Most of the time, it's the ground. Is it above the ground? And if it is yes, then the potential energy is going to be non-zero. In other words, it will have potential energy. And if it's at the ground level, in other words, is it above the ground? No. It will have zero potential energy.